Number 47 wants us to find the z-value to the left of the mean so that A, 98.87% of the area under the distribution curve lies to the right of it. So for A, just remember that the mean is 0 when you're doing these distribution curves. And if you want to see that, you can go to page 313 of the 9th edition of Elementary Statistics by Blumen. So when we draw a distribution curve, 0 is in the middle, 0 is the mean. They want 98.87% of the area to the right of the mean. So remember, this whole area under the curve is 100% or 1, same thing. So they want most of it to the right. So we're drawing our line there, and we are shading to the right. And we know this here is 98.87% of the area under the curve, which if we convert that to a decimal, that's 0.9887. When we're dealing with our distribution curves, we want to convert them to decimals so we can do math with them. And to do that, you just take your percentage, divide by 100, you will get your decimal. But to look our area up in our chart, we need our area to the left. So in order to get that, the whole area under the curve is 1 or 100%. So we take 1 minus 0.9887, and that gives us 0.0113. So this area here is 0.0113. That's what we want to look up in our chart to find z. Now remember, 0.0113, we're looking up here. We're not looking it up here or here. We're looking for that number in here. So based on that, let's try and find that. 0.0113 is right here. So that area corresponds to this z value, negative 2.28. So here, z is equal to negative 2.28. So if we were to do that in our calculator, let's go to our calculator. We go to second bars and inverse norm, number 3. Type in our area to the left, not to the right, but to the left. 0.0113, close parentheses, enter, negative 2.28, which is what we got for A. Now for B, let's do B. B says they want the area under the distribution curve, 82.12% of the area to the right. So when we do that, same concept, our z value is unknown, that's what we're looking for here. The area to the right of the value, and this area to the right is 82.12%. Convert that to a decimal, divide by 100, it's 0.8212. We want to work with decimals here. But again, we need the area to the left to be able to put this, to look this up in our chart or put it in our calculator. So since the whole area under the curve is 1, we do 1 minus 0.8212 to get us the area to the left. So 1 minus 0.8212 gives us 0.1788. So this area to the left is 0.1788. So let's look that up in our chart here. So we know this number will be negative because the area, or we know since this area is going to be to the right of the mean, they want most of it to the right. So we're going to shade to the right, and because most of the area is to the right, we're going to have a z-value on the left side of 0, and since the z-value is on the left side of 0, the z-value must be negative. So we can go straight to our negative distribution chart. So let's look for 0.1788. So 0.1788. Getting close down here, right here, 0.1788. So that number, that area corresponds with this z-value, negative 0.92. So when we go here, we get our z-value is equal to negative 0.92. Again, let's do it in our calculator. We go to second bars, inverse norm. Area to the left we plug in, not to the right. So 0.1788. Enter. Negative 0.92. Two decimal places only with the z-value, so negative 0.92. Now for C, they want 60.64% to the right of the mean. So this is 60.64%. To the right of the mean. Here's our mean, which when we convert that to a decimal is 0.6064 as a decimal. Same thing, we need the area to the left in order to work with it in our chart and our calculator. The whole area under the curve is 1 again, so we do 1 minus 0 points with negative 0.27. So our z value is negative 0.27. And one last time in our calculator, second bars, inverse norm, plug in the area to the left, 0.3936, close parentheses. Our z value is negative 0.27, which is what we got here.